All right, we are starting 8.3 notes. We're going to be talking about regression lines today and residuals. So I have some terms that I'd like us to know about first. One is regression line. Now it says y hat. So y hat means prediction. Our prediction line is our y-intercept plus our slope times x. So you probably recognize this as mx plus b. Where b is your y-intercept and m is your slope. We're just using different terms for slope and y-intercept, but they're the same thing. So it provides a line of best fit equation that we can use to make predictions. The difference between, the residual is the difference between the actual value and the predicted value. So the actual y value minus the predicted y value. So we're trying to find how far away is our prediction from the actual value. And then we have interpretations of slope and y-intercept. So slope is found by multiplying the correlation coefficient times the standard deviation of y divided by the standard deviation of x. So remember that slope is the change in y over change in x. Thinking about that change here, variation, right? The variation of your values. So variation of y divided by variation in x. And then we have our interpretation here. When x increases by 1, y increases or decreases by b. So if you have a negative slope, it's decreases, a positive slope, it's increases, and then that b value is whatever you find here. All right, so next, interpreting y-intercept. Y-intercept is the value of y when x equals 0. The y bar is your mean of your y values, your x bar is the mean of your x values. And here is how you calculate that. Y bar minus your slope, B1 was slope, times x bar. And then we have a couple of things here that we just need to know about, maybe a different term than you've heard before. The outcome variable is the dependent variable. It's the output value, probably y that you know of it as. The predictor variable is the independent variable. It's the input, otherwise known as your x value. It's the variable used to predict another variable. So a couple of new terms here, but probably, hopefully, familiar. All right, so I want to try, if you wanted to pause or go back and put those down, let's try an example together to see if we can predict height based on a woman's shoe size. So we have, it's a woman's shoe size. So below are statistics, and it tells us shoe size and height. So if we're predicting height based on shoe size, then our shoe size is going to be our predictor variable, x, and our height is going to be our outcome variable, y. So I'm trying to predict height based on shoe size. So it tells us our statistics here for shoe size and height, and it also tells us our R value of 0.7. So we know that it is a moderate positive correlation. We have some down here that are not quite so close to our values or our predicted line. So let's determine what our slope and y-intercept are based on these statistics. So let's identify our variables and then calculate. So our R value we know is 0.7. Our standard deviation of our Y value here is 4.32. Our standard deviation of our X value here is 2.39. So going back to our formula up at the top was the R value times the quotient of our two standard deviations. So we have 0.70 times 4.32 divided by 2.39. And that comes out to 1.27. So we know that we have a positive slope. We can verify that by seeing that our linear regression line here is also positive. That's what helps. Now let's find our y-intercept. So our y bar is 65.11. I just got that from here. And then our slope we just found was 1.27. Our x bar, which is up here, is 8.91. And then let's calculate 65.11 minus 1.27 times 8.91. And that gets us a value of 53.79. So let's interpret what these two things mean by flipping it over. All right, so our slope in this context means that as your shoe size, as our x values, right, as shoe size increases by one shoe size, height also increases because our slope is positive by 1.27 inches. So it's a positive slope. As your x value increases, your y value also increases. All right, let's do our y-intercept. So when our y-intercept was when the value, it's the value of y when x equals 0. So when your shoe size is 0, the height is 53.84 inches. Now, sometimes your prediction line kind of falls apart because this is not realistic, right? Nobody has a shoe size of 0. So therefore you can't really predict the height based on a shoe size of 0. But this is the interpretation of it, right? So let's plug it in. We had our y hat, right? Our predicted line. And then our y-intercept, which was 53.84 inches, plus our slope, 1.27 times x. Now, I know for many of us in algebra, we usually put 1.27x first and then the y-intercept. These are the same thing, they're interchangeable. In statistics, we like to think of it as a plus bx, or b of 0 plus b of 1 times x. So once we have a linear regression equation, we can use it to predict a value of y based on some x. So let's suppose we know that someone's shoe size is a 6. We can use the model to predict their height. So since our x values are shoe size, we're going to plug in 6 to determine the predicted value. So we'll plug this in and multiply, and we get the predicted value of 61.41 inches. So my prediction is that someone who has a shoe size of 6 is 61.41 inches. So if we knew the actual value of y, so this is our predicted value, 61.41 inches. If we know the actual value of y, we can see how far off our prediction is. And that is called a residual. So let's determine what our residual is. So our residual is the actual y value minus the predicted y value. So our actual y value, they tell us, is 60 inches. Well, let's say in our scatter plot, the actual point was at 60. So our actual y value was 60 inches. We're going to subtract it with this predicted y value of 61.41 inches. So we're a little bit off, right? So this predicted value is a little bit higher than our actual value. So we're going to get a negative 1.41. So we're off by 1.41 inches, which means if we get a negative residual value, it means that we have over-predicted. Now, when you're a statistician and you're looking at linear regression lines, we want to make sure that we don't consistently overpredict or underpredict. That if we put all of our residual values together, they're pretty much 0. That's the goal. All right, so you're going to try this. We're going to calculate the residuals below given the line of best fit and the observed values. So we have our actual x and y values here. And then we have our predicted line, predicted regression line. So if our x value is 2, then our predicted value would be half of 2, so it'd be 1, right? If our x value is 4, then our predicted value is going to be 2. And if our x value is 6, our predicted value is 3. If our x value is 7, our predicted value is 3.5, half of that. And our x value is 9, then our predicted value is half of 9, so 4.5. So all I did was plug in x for x here to figure out the y hat. All right, so if our actual values are written down here for our y values, here's our predicted values. So to find the residual, you're going to subtract the actual minus the predicted. So 2 minus 1 is 1, 1 minus 2 is -1, 3 minus 3 is 0, 3 minus 3.5 is -0.5, and 5 minus 4.5 is +0.5. I'm going to put a 0 there. All right, so our residuals, you can kind of see that some of them are over and some of them are under, right? We'll talk a little bit more about this next class. We could also plot these here so we can tell a little bit. There's 2, 1, sorry. Wait, 2 predicted. Oh, this is our predicted. 2, 2 was our actual. 4, 1 was here. 6, 3. It's hard to say. Yeah, that one was right on. 7, 3. A little bit off. And then 9, 5. It's a little bit over. So you can see, minus the mistake that I made here, that some of the residuals are over, some of them are under, and then one of them is right on. So from this information, we can also calculate R squared, and I'll show you how to do that on the calculator to determine the percent of variation in the dependent variable that is explained by the independent variable. So if our R squared value is 72, that means that 72% of the Y values can be explained by the X values. So we're going to go over more of this in class together, but hopefully that gets you understanding slope and y-intercept, and we'll be able to practice it together.